Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving find minimum time to reach last room 2. If you haven't solved find minimum time to reach last room 1, I would recommend solving that one first because the solutions for these two problems are very similar. It's just one small twist, so even the coding is only different in one line. But anyways, the problem states that we are given a 2D array move time of size n times m, and move time at ij represents the minimum time in seconds when we can start moving to that room. And we want to start from the room 0, 0 at time 0, and then we can move to an adjacent room one at a time. So adjacent meaning we can move one to the right, one to the bottom, one to the top, or one to the left. And moving between adjacent room will take 1 second for one move and 2 seconds for the next move. And it will alternating between 1 second and 2 seconds. And we want to return the minimum time it can reach to the bottom right corner. So n-1 and minus 1 as the coordinate. So if you look at this example, it will take 5 seconds to come here or 5 seconds to go from here to down here. So we can take either route, and it takes 5 seconds because we have to wait 4 seconds to be able to move, and it will take 1 second to move over, and the next move will take 2 seconds to move over. So either way, it will take 2 seconds because it's already past 4 seconds. So we just need to wait 2 seconds, and 5 plus 2 is 7. So that's why we return 7. So now that we have seen some examples, let's get to how we can solve this problem. So we realize that the main twist to this problem compared to find minimum time to reach last room 1 is we need to figure out when we go to adjacent room, will it take 1 second or will it take 2 seconds? So I draw it out in coordinates. So the left point represents which row they are in, and the right point represents which column that they are in. And we realized that to figure out if we should take 1 second or 2 seconds to get to that room, and we realized that we can use this formula to figure out if the coordinate sum is even or odd. And if it is even, then it'll take 2 seconds. If it is odd, then it will take 1 second. So for example, 1 plus 0 is odd, so it'll take 1 second to come here. This is also 1, so take 1 second to come here. And if we look at this one, it will take 2 seconds because we will either have to come through here first to come here or come through here first to come here. So it will be 2 seconds no matter what. And as you can see, 1 plus 1 modulo 2, it's 0, so it's even. So that's why it's 2 seconds. And then we can do that for all the coordinates. And the rest of the problem is mainly just a Dijkstra algorithm. So we will initialize a heap. So this will indicate the time to get to that room. And this is the row and this is the column. And every time we pop from the heap, we will see the directions that it can go. We'll look at these 4 directions and add all the time to get all the rooms that it can reach to the heap. And then we will update the times at the timetable over here. And each time we pop, we also indicate that it has been visited. So we want to add it to the visit set to make sure that it has not been visited again. So let's go over this example real quick. So we first pop this from the heap and we realize that it can reach here in 16 seconds. It can reach here in 19 seconds. So that's why we add them and we update times and add to visit. So now we'll pop this one since it's the smallest. And we realize that this place has been visited, can go here, but it will take 18 seconds to come here since it takes 16 seconds to come here, and we will have to add 2 seconds to get over here, so that's why it's 18. And then now we will pop this from the heap and we realize that this has been visited, this has been visited, but we can come here. So we will add 51 because we have to wait till 50 seconds to come here, and it'll take 1 second to come over because this is row 1 and column 2, so 3 mod 2 would be 1, and which means it's odd. So now we will pop this one from the heap and we realize that we can come here in 22 seconds because we have to wait till 20 and it'll take 2 seconds to come over, so that's why it's 22. We update the times table, add the coordinates to visit, and then now we'll pop this from the heap, realize that we can come here in 31 seconds, so we add that here, and we want to add this to the visit set and update the times table. And now we'll pop this from the heap. Then we realize that it will take 33 seconds to come here because it takes 31 seconds to come here. And we have to wait 2 more seconds because this is row 1 and column 3, which 1 plus 3 mod 2 is 0. So it's even, gotta wait 2 seconds. So that's why 31 plus 2 is 33. And now we'll pop this from the heap. And we realize that this has been visited, this has been visited, can go here. So we don't add anything to the heap. We just add the coordinate to the set. And then now we'll pop this from the heap. And same thing, everything can go here, can go here, can go here because they have all been visited, and we obviously cannot go downwards. So we just pop from the heap, and now that the heap is empty, we can return the result over here, which is 33 seconds. So we return 33. And the time complexity would be O of nm log nm, where n is the number of rows and m is the number of columns, because we will iterate through the number of rows times number of columns, and then each time we pop from the heap and push to the heap, it will take log of nm time. And the space complexity would be O of nm, because both the times table, the visit set, and the heap can take up to nm space, which means the number of rows times the number of columns. So now let's get to the coding part. So first we will initialize the length of rows, or the number of rows, so length of move time, and the number of columns will be length of move time of 0. And now we will initialize a times table, so float infinity initially for all the coordinates or all the rooms, and then we will set the first room to 0 after we have initialized all to infinity. So times at 0, 0, and initialize the min heap, so we will start with just 0.0, which indicates the time to get there, and row 0, column 0, so all 3 zeros, and then initialize an empty set for the places that have been visited and the directions to indicate where we can move to adjacent rooms. And -1. And now, while the heap is not empty, we will keep pushing and popping. So we'll pop first. So TRC will be time, row, column. And if that point has already been visited, then we'll continue. Continue. Otherwise, we will add it to visit. And now we will look at the directions that it can go in. So for dr, dc in directions, nr, nc would equal to r plus dr and c plus dc. So, and we want to make sure that the new row, new column, so that's nr, nc, they are not out of boundaries. So we got to make sure that they are within 0 and rows and 0 and columns. But if they're out of boundaries, then we'll continue and look to the next one. Otherwise, now we calculate the time. So it will be the max of times at row column, or the move time at the new row and new column. It will be the max between those two. And then we will add row plus column modulo 2. So if it is odd, we add 1 and 1. And if it's even, we just add 1. And if the time that's calculated happens to be less than the times table at new row and new column, then we will update the times table. And then we will push that new row and new column to the heap with the time attached. So we'll heap push, and then finally we can return the bottom right of the times table. So it will be rows -1 and columns -1. And let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave it in the comment section, and I hope to see you all again soon.